Hi guys, this is Sarah, and today I'm going to describe the basic principles of a t-test. So the first logical question we have to ask ourselves is, what exactly is a t-test? The goal of a t-test is to test the null hypothesis that the mean of one sample is equal to the mean of another sample. For example, you could analyze the amount of time people in New York spend on public transportation in comparison to people in Nebraska. Now, it's impossible to ask everyone in New York and Nebraska how many hours a day they spend on public transportation, so that's why we would take a sample. Remember that the larger the sample size, the better, because as the sample increases, the mean of the sample will more accurately reflect the unknown mean of the population. Our null hypothesis would be that the hours spent on public transportation in New York equals the hours spent on public transportation in Nebraska. After we conduct our experiment, we find that New Yorkers spend 10 hours a week on public transportation, while Nebraskans only spend 2. A t-test will tell us if the difference between two sample means, aka 10 hours for the New Yorker and 2 hours for the Nebraskan, are unlikely to have occurred because of random chance in sample selection. As with all statistical tests of significance we've learned this semester, there are certain criteria for conducting a t-test. First, the sample must be independent, meaning the outcome of one sample doesn't influence the outcome of another sample. The samples must be random, the populations are normally distributed, and in reality there's a bit of wiggle room on this one. As long as the populations have similar distributions with no outliers, that's good enough. And the population mean and standard deviation are unknown. Now we're going to go into the real substance of a t-test. The first step is to calculate the t-test statistic. This is pretty simple. Just fill in the variables given to you in the question and do the algebra. Now, every t-test statistic has a corresponding p-value. According to Dr. Taylor at Anderson University, the p-value will, quote, tell us the probability that the observed statistic occurred by chance. You can determine the p-value by using a t-table. The first thing you want to do is calculate the t-test statistic. Let's say, for example, our t-test statistic comes out to be 0.873. Next, we want to calculate the degrees of freedom, which is the smaller of n1 minus 1 or n2 minus 1. For example's sake, let's say that our degrees of freedom is 12. We would then pull out our t-table, and we would find that 12 degrees of freedom on the left side of the chart and its corresponding t-test statistic, 0.873. This correlates with a p-value of 0.2 or 0.4, depending on whether our test is one-sided or two-sided, something I'll explain later. Now that we have our t-test statistic and the corresponding p-value, what do we do with it? This is where things get a little trickier, so I'm going to diverge a bit and talk about alpha, and then we'll tie this all together later on. So alpha is an area under the bell curve that basically tells us how extreme results have to be in order to reject the null hypothesis. This is derived from the confidence level. So if we have a confidence level of 95%, our alpha would be 1 minus 0.95, or 0.05. So hold on to that thought. Now, how are the p-value and alpha related? If the p-value is less than or equal to alpha, we can reject the null hypothesis and state that our test is statistically significant. In this diagram, p-value correlates to the yellow part of the chart. Conversely, if the p-value is greater than alpha, we can fail to reject the null hypothesis and state that our test is not statistically significant. Now, remember a few slides back when I showed you guys that the corresponding p-value could be 0.2 or 0.4, depending on whether the t-test was one or two-tailed. Now we're going to discuss exactly what that means. We can use a one-sided t-test if we are only interested in one side of the distribution. The one-sided t-test tests the alternate hypothesis that mu is greater than mu naught or mu is less than mu naught, but not both. So I'm going to use an example from Stats Portal to quickly demonstrate how and when to use a one-sided t-test. In example 19.2, researchers at the Mayo Clinic are interested in the following question. Do lean and obese people differ in the average time they spend standing and walking? So there's pretty smart people over at the Mayo Clinic, and they use common sense to suspect in advance that lean people are more active than obese people. And this yields the following hypotheses. The collected data is described in this chart, and we can use this data to construct our t-statistic, which comes out to 3.808. Our degrees of freedom is 9, and remember that's just n minus 1, and our t-test statistic is 3.808. Looking at our handy t-table, we have locate 9 degrees of freedom and move to the right until we find an interval that captures our t-statistic, which in this case is 3.690 to 4.297. These numbers correlate with a p-value between 0.025 and 0.001. If we assume that our alpha is 0.05, then the p-values for our one-sided t-test statistic are smaller than alpha. Therefore, we can reject the null and say that there is very strong evidence that lean people are more active than obese people. Finally, we have a two-sided t-test, and we can use a two-sided t-test if you are interested in both sides of the distribution. The two-sided t-test tests the alternate hypothesis that mu is not equal to mu naught, but we don't know in what direction. Now for one more example from the book demonstrating how and when to use a two-sided t-test. Example 19.5 wants to answer the question, are college students who participate in community service more attached to their friends? The researchers have no preconceived notions about the results, so we want to examine both sides of the distribution and construct the following hypotheses. Here is our data and our lovely t-statistic, which comes out to be 2.142. Our degrees of freedom is 16, and our t-statistic is 2.142. Using the t-table, we would locate 16 degrees of freedom and move to the right until we find an interval that captures our t-statistic, which in this case is 2.12 to 2.235. These numbers correlate with a p-value between 0.05 and 0.04. Now, this kind of puts us in a tricky spot because the p-value is not that much smaller than alpha, but with that said, we can say that there is moderately strong evidence to reject the null, and from hence we can conclude that students who are engaged in community service, on the average, are more attached to their friends. Okay, so just a quick review. Today we described the conditions necessary for conducting a t-test, learned how to do a t-test for one-sided and two-sided alternatives, learned how to interpret the p-value and alpha, and how to integrate p-value and alpha to determine statistical significance. Okay, that's all I have for you. I hope you guys learned something, and thank you for watching.